Okay, so these are the promised solutions to those challenge problems. This first challenge problem is particularly difficult, probably the hardest of the five. And the key to this problem is first looking at each individual student. So let's take a look at Amy and what her possibilities are. Well, Amy's possibilities are she could do swimming in the spring and she could do track in the fall. We'll do T for track. And then she could also do swimming in the spring or in the fall, my bad, and tennis, and we'll do T1 for tennis in the spring. Then you could keep doing the same process, make it football and tennis, or football and track and football and tennis, and then finally volleyball and track and volleyball and tennis. So it turns out that there are 6 different possibilities for Amy. But it turns out that means then for Brian and Charlie, it's the same 6 possibilities. So each of them have 6 possibilities they could choose from. So when you combine things like that together, you use what's called the fundamental theorem of counting, which means if you got 3 different things that you want to put together and they each have a certain number of possibilities, you just multiply those possibilities together. So the total number of ways that this could be chosen is 6 times 6 times 6, which is 216. Each of them have 6 ways. They could pick their sports. Do 6 times 6 times 6, you get 216 total ways that all 3 of them could pick their sports. Because, if Amy picked swimming and track, then Brian could pick any of the 6, and Charlie could pick any of the 6. And so there are actually 36 ways that those 2 could pick their sports when Amy picks swimming and track. And so that's why this fundamental theorem of counting works. Now that's the total possible, and whenever we do probability, we do the possible that we want over the total possible. Well, the possible you want is they choose the same sport. Well, there's only 6 ways they can do that, right? There's one way they could all 3 choose swimming and track. There's one way they could each choose swimming and tennis, so on and so forth. So there's 6 total ways. So the answer is 6 over 216, which is 1 over 36. Like I said, that one's a pretty tough one. So if you didn't understand that one, don't be too concerned. Okay, 22. This is a really good one. And this will teach you can learn something really good from this one. Essentially what's happening is we're going to be summing this. On the first day we got 1 coal. Second day 2, third day 4, fourth day 8, and so on and so forth. It says how many total lumps. That's why we're adding them up, not how many at the end of the 10th day, like how many on that 10th day. So you got to keep adding up, and hopefully you notice what's happening. The pattern here is you're multiplying by 2. So that's day 9. Go through and count, and so my 10th day is 512. Now, one way to solve this problem at this point is to go through and add all those numbers together. And that's a perfectly valid way to do it, but it's not the fastest way. The fastest way is to notice a pattern. 1 plus 2 is 3. Notice 3 is less than 4. 3 plus 4 is 7. Notice 7 is 1 less than 8. 7 plus 8 is 15. 15 is 1 less than 6. And so what happens is you notice a pattern when you have this, which these are what are called the powers of 2. If you start from 2 to the 0, plus 2 to the first, plus 2 to the second, 2 to the second is 4, 2 to the third is 8, to 2 to the 9th, which is what we did here, because 0 is the first day, so 9th is the 10th day. Well, it's always going to be 1 less than 2 to the next power. So 512 times 2 is 124. Subtract 1 because that's what our pattern was, right? And you get 1023. And that's the correct answer. Okay, next problem. From a list of 1-digit and 2-digit counting numbers, Bertie crossed out multiples of 9. All the numbers she would say when counting by 10, starting with 3, 13, 23, etc., and all the numbers containing the digit 4. Well, first, we know we're going from 1 to 99, so we know we're talking about 99 numbers. The hard part on this one is you can't list them all out. It would just be too difficult. So instead, we need to start subtracting things away. So the question is, how many multiples of 9 are there? Well, the first one's 9, and then 18, and then 27, and all the way to 99. Well, since this is 9 times 1, and this is 9 times 11, that means from 1 to 99, there are 11 multiples of 9. So if I'm going to cross those out, I've crossed out 11 numbers. The number of numbers here that I'm counting from 3, 13, 23 to ... all the way to 93. Well, when you do this, there's always going to, you're counting by tens in 100, there's always going to be 10 ways to do that, so we're going to subtract 10. Now, we do have to be careful because we may be overcounted, because it's over-subtracted, because it's possible one of these is also one of those. And it turns out one of them is, and that's the number 63. So when I subtracted 11, I crossed out the 63. And when I subtracted the 10, I crossed out the 63. So I actually need to add one back for that 63 because I crossed it out twice, and we don't want to cross it out twice. All right, last one is all the numbers containing the digit 4. Well, that's going to be 4, 14, 24, 34, all the numbers from 40 to 49, and all the way to 54, 64, 74, 84, 94. Now, there are 10 numbers here, so there are 19 numbers that contain a 4, if you go through and count those up. Now, again, the problem is, though, that we subtracted away some that we've already subtracted. Were any of these multiples of 9? Well, yeah. 45 is a multiple of 9, and 54 is a multiple of 9. So I've subtracted two away there that I shouldn't have. Do any of those end in a 3? Well, yeah, 43 does. So there were 3 extra, so I should have added 3 back, which gives me the answer of 63. Okay, next one. Jimmy has 7 chapters, each has 14 pages, and at most 27 pages. Chapter 1 starts on page 1. Each chapter starts on a new page, and each chapter has a different number of pages. What is the lowest number of pages? Well, to do this, what we need to do is, whenever you're trying to minimize something, then you just figure out the extreme least possible. So that would be chapter 1 going from page 1 to 14. It has to have at least 14 pages. Chapter 2 has to have 15 pages. But if you remember in class, we're not going to add 15. Instead, we're going to add 14. Because when I count the number of pages, 29 minus 15 is 14, but you always add 1 to count the number of pages, so there are 15 pages there. So chapter 2 goes from 15 to 29. Chapter 3 is going to go from 30. You add 1 less than, because we're adding 16 this time. 14 pages, 15 pages, 16 pages, so it's going to be 45. Always add 1 less. Then from 46, we're going to add 1 less than 17, so that's 62. Then at 63, we're going to add 1 less than 18, so that's 80. So you're adding 70 to it. That's chapter 5. Chapter 6 starts at 81. You're going to add 18 to that to get to 99. And so the lowest page that you could have possibly have got in chapter 6, my bad, I already did chapter 6, was 81. So the correct answer to this problem was 81. Okay, so we're not going to go ahead and do chapter 5 because of time constraints on this video. I hope you learned something from those 4. If you want to know how to do number 25, maybe we can talk about that in class on Wednesday.